let me go ahead and get a couple other housekeeping things set up and introduce myself. So this is me. I'm Eric Gross. I've got the hat on because I'm covering the fact that there's a little more gray that is in the hair. I don't care if my hair goes gray. I really don't. Okay. I just like the hat. My wife and I had a very long planned trip to Italy that we pulled off this spring. And while I was there in Venice, I bought this hat. And so now it lives on my head. So yeah, I'm an engineer, a software developer, a coder, a programmer, whatever you want to call it. There's a lot of words out there, right? But I've been, living and breathing software and computers since I was around 11 years old. Um, uh, I'll answer a couple of those questions in terms of where we're going to write our code. We'll take care of that. It's online. Okay, you don't have to worry about that at all. I'm a veteran. I was in the Navy for 6 years. I was a nuclear reactor operator and electronics technician in the Navy, and that's where I first taught classes. I was voluntold. Yes, that's the right word, because in the Navy, you get told what to do. You don't get asked what to do. And I was voluntold to teach classes. It scared me to no end, and it turns out I loved it. I'm also the co-founder of the Tech Academy, the school that puts on these free classes. More about that later. We do have a couple guidelines to go over. We have an assistant in the chat. You will see that Cheska is there in the chat, monitoring, answering questions, all that kind of thing. Wow, people from Ireland and everything. This is fantastic. Her job, again, is to monitor the chat and answer questions, and also to remove problematic students. We haven't had that happen in a year, so I'm never that worried about it. We get great people in these classes. A quick note about writing code, because we're going to start writing some actual programs here in a few minutes. Make sure that when you're writing code, I'll go slowly, okay? And make sure that you write your code exactly as I wrote it, exactly as written. And the reason for it, without getting into a bunch of nerdy stuff too quickly, is that things like a misspelled word or a missing symbol, or even something's capitalized that shouldn't be capitalized, can result in errors in your code. So just write it exactly as I put it on the screen. Make sure you're in a distraction-free environment so you can focus on the class and so I don't lose you. I really want you to get as much as you can out of this class. On that, if you do fall behind with writing the code, don't worry about it. Just listen and learn. You'll still learn a lot, even if you lost track of all the code we're writing, okay? All right. A lot of people ask, do we record these? Can we get the recordings? Absolutely and absolutely. They're recorded, and the recordings are generally available within about a day or less up on our free YouTube channel, and we'll get you the links to that to the end, okay? There's also the full code to the game that we're going to look at today is available to you as well at the end of the class. So you get all the code so you can play the game and mess around with the code, okay? And really, that's it in terms of basic guidelines. You all know how to use the chat, right? And you've all been awesome in letting me know where you're joining from. I didn't say I'm in Louisiana. Yes, the Louisiana that just had a hurricane 2 days ago. And yes, the hurricane hit us. So we only just got Wi-Fi back this morning. So I'm really glad that I'm able to teach this class right now. We escaped relatively unscathed. We had massive wind, massive rain, a lot of flooding, but our house is elevated, and so it flooded down below, but not much bad happened. Okay, so it's pretty wild. I'd never been through a hurricane before. Don't know that I want to repeat it. So here's the basic agenda of the class. We'll have a short explanation of the Tech Academy, and then we're going to write some code. I try to answer questions as I go through the coding, but time permitting, we'll have a brief Q&A session after we're done writing the code. We'll then go over some information about our boot camps, and especially if you're thinking about a career in technology, there's a lot of really valuable information that we'll impart. And as I mentioned, there is a free gift for you at the end, so please stick around for that. The whole class should take about an hour to an hour and a half. So I'm just going to get started with a few fundamental things just about the Tech Academy. I'll be very quick here. We deliver boot camps, which are intensive technology certification programs. They're designed to prepare people for entry-level jobs in tech. Depending on which boot camp you go to, because there's hundreds around the world, right? They typically last 3 to 6 months, and they focus on practical, modern skills, how to prepare you to enter the tech workforce, right? Now, at the Tech Academy, we've been offering very thorough, budget-friendly, flexible, trusted coding boot camps for over a decade. We were around at the beginning of this industry, right? The programs are cost effective. They're self-paced, which is kind of unique. They're fully online and they're tailored for beginners, people that have no prior technical or coding knowledge. They cover in-demand skills. They're endorsed by stellar online reviews, and they're really flexible. They can fit around your personal schedule. We try to prepare people for a tech career with a really well-rounded toolkit. In terms of pricing, the average price for boot camps in America is around $13,500. Our programs are well under the national average. In fact, we have programs that start as low as $59.80. And the last thing I like to say on this is our mission statement. Why do we do these free classes? Why do we have the boot camp? Why are we even here? Our mission is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. That's why we're here, and our product is you working in tech. All right, so a couple basic definitions before we jump into coding. The first one is, what's a program? This is just a series of written instructions that are entered into a computer that make the computer do things. That's what a program is. Now, if you've never done any coding, you've used programs, but not created them. Now you get to become the creator of programs. And you do that using what's called a programming language. It's just a very precise set of words, phrases, and symbols that allow you to communicate with the computer and tell it what to do. The programming language is what you use to make programs. And finally, there's the word coding. It just means the action of putting those instructions into the computer. That's what coding is. And they're just text. You just type in text, instructions, and then when you tell the computer to do those instructions, it does. It does what you told it to do, which is kind of cool. All right. Now, we are using the language JavaScript to do this. JavaScript is a really popular programming language developed in 1995, right at the birth of the World Wide Web. And it was originally designed to make it so that websites could have interactive elements. Now you can use it for that, of course. JavaScript is used a lot in websites and web programming, but it's really versatile. You can do all sorts of other programming with it, okay? Then there's HTML. It means hypertext markup language. This is the language of the web. This is the language you use to make web pages. More precisely, it describes the appearance of a web page, the content of the web page. That's what HTML is for. And then finally, there's CSS. It means cascading style sheets. This is a technology you use that controls the appearance of the content on the web page. Do images have borders around them or not? What color is the text? What font is the text? All of these things and more can be controlled with this thing called CSS. All three of these together, JavaScript, HTML, and CSS, those are the core technologies of web development. So learning JavaScript is a pretty smart route to go because almost every bit of computer technology nowadays uses the web in some way, okay? All right, so here is the most valuable slide in this entire class. The most valuable thing that we can present to you is not the coding, although the coding is really awesome and fun. It's the contents of this slide. On this slide, what we're going to do is go over the 5 fundamental elements of any computer program. These are the only things there will ever be in a computer program. And once you understand the fundamentals of these, your journey of learning to code gets a lot easier. And learning a second language gets a lot easier. So let's dive into it. The first fundamental element of any computer program is what we call an entrance point. Really, this is where does the program actually start doing work? And it's actually more important than you might think. First of all, when you start a program running on your computer, the computer has to do a bunch of things under the hood that help your program work. One of the most important ones revolves around what we call memory devices. Inside your computer, tapping on my computer right here, inside the computer are little devices called memory devices. They're usually about 3-4 inches long, and they're stuck inside your computer. And this is where data is stored. More precisely, what gets stored in that device is all the information your program needs while it's working. Let's say you have a program that revolves all around a school. You run a school, so I'll use that as an example. You might need to store the information about all your students. And it would be stored in this little memory device. Like I said, it's only about 3 or 4 inches long, but it can hold literally billions of pieces of information, which is pretty cool. Why do I bring this up? And how does this relate to this entrance point? When you start your program running on the computer, your computer goes into the memory storage devices and blocks off a certain section of the data storage that's available and says this section is only for this computer program that started up. And from that point forward, no other program is allowed to mess with the data in that section. It keeps the data safe. And so this entrance point is very useful for the computer to know, hey, a new program has been started. I better reserve some storage area. But there's another reason that relates to you, the programmer. Another reason why this entrance point is so important, why it's so cool. Let's say you break into tech, however you do it. You go to college, you go through a boot camp, you self-taught, whatever. And you get your first technology job and you join a team, and that team's responsible for maintaining a really big program. And within the first few days or weeks, you've got to start learning that program. The entrance point is going to be your most valuable tool for studying this new program. Because if you can find the very first instructions that get performed, the moment that computer program turns on, that's your best place to start in figuring out how this program works. You can just step through one instruction at a time and see, how does this program start itself up? What are the initial things it configures? How does it do its job? If you were to start at random halfway through the program somewhere, you'd have a much harder time understanding really what the program does. So I know I said a lot about this entrance point. It's actually really valuable. And of course, every program has one. The next thing that every computer program makes use of is what are called variables. Variables are just pieces of data that your computer program is using, but more precisely, they're pieces of data that can change while the computer program is running. You need to be able to keep track of these. For example, let's say you run a scheduling program for a high school, and you are limited by law to have no more than 28 students in a given class. And you're arranging the schedule for the upcoming school year, and you're trying to allocate students into each class, and you start to add a student to a class. You want to know how many are already in that class. Because if it's 28, you might not want to try to add them. And of course, it can change. So that's where variables come in. If you didn't have that ability in a program to keep track of data that could change, your program wouldn't be very useful to human beings. The next element that's in a computer program that's vital for the program to be useful to people is what are called control and branching instructions. This is what you use to make a computer program make a decision, which is super valuable in a program. Let's take that example of you're trying to schedule students into a class. If you tried to add a student to a class and it was limited to 28, then you would have to program the ability for the computer to make a decision. Do I add the student or not? Well, if there's already 28 students inside that class, then the answer is no. But if there's only 27, then the answer is yes. I know it sounds like a simple example, but this is part of what makes computer programs so valuable. They can enforce rules and logic, and they can make decisions if they're told ahead of time what the criteria are for making the decision. You set those criteria using control instructions, and you use branching to have what are the options that I have available to me. You're going to see all this in code in a few minutes. You're going to build these things in code. The next element of a computer program that's vital is what's called a subprogram. You can think of these, as it says, as programs within programs, and they're super valuable to you as a programmer. Here's how they came about in the first place. Way back when, 70, 80 years ago, at the dawn of this whole computer programming area, programmers found that very often when they were creating a long, big program, that there would be certain steps that they would need to do many different times as the program was running. It might be capitalizing all the content of a file. It might be putting a list of numbers in ascending order or whatever. But the point is that these programmers found that they were doing the same exact set of steps many different times in a program. And not only was this like wasted time to type in the exact same instructions, but it also was error prone. What if they didn't type it in exactly the same way each time? And worse yet, what if they needed to make a change to how they did those steps? They'd have to go back through this huge program and find every place where they did this identical series of steps. And so finally, some bright person went, hey, this is silly. Why don't we take this identical series of steps and just wrap it up in a little box and give it a name? And then when we're writing our program, whenever we need that series of steps to happen, we just call on the box and say, hey, do what's over here. And when you're done, come back and pick up where you left off. That's what a subprogram is. And again, you're going to build one tonight. They're super, super valuable. The last element of any computer program is an exit point, the final instruction, the point at which, and this is why this is important, the point at which the program says to the computer that it's running on, I'm done. I'm out of here. This program is terminating. Now, there's a few things that the computer can do at that point, but one of the most important ones relates to what we talked about with the entrance point. The computer can go inside that memory storage device where it had reserved a bunch of storage area for your program and release it. It's now available for other programs to use. So there you have it on the screen. These are the 5 fundamental elements of any computer program. And as I said, these are the only things you will ever find in a computer program. That's all that's in a program. Now, they're not always in this exact order. The entrance point and the exit point, of course, are at the beginning and the end of the program. But inside there, you make up your program and what it does using variables and control and branching instructions and subprograms. And that's all there is. That's it. All right. Now, let's get coding. To do that, we need a code editor. And a code editor is just some sort of program where you can type in your instructions and then tell the computer to run them. That's what a code editor is. Type your instructions and tell the computer to do those instructions. We're going to do that in this online code editor. So in chat, if I could have, let's see, Cheska, can you drop, there it is. Cheska just dropped a link into chat. It's the same one you see on the screen here. Go ahead and click on that link, and it will open up a browser tab for you. That's going to be your code editor. Now, don't worry about what's already in there. We're going to take care of that. But the first thing we need to handle for this to go well for you is we need to set up you having me and your code editor side by side. If you have 2 monitors, then you're in luck. You can just put me on one monitor and your code editor on the other monitor. If you don't have that, then here's what you can do. We can do a split screen. On the left will be me, because I'm going to have the code editor open too here in a moment. On the right will be you. To do that, you need to take the Zoom meeting, which is me, I'm in the Zoom meeting, and put it on the left-hand side. If Zoom is being painful for you and doesn't want to resize and move around, you can click on the words Zoom meeting and this little restore button appears. Click on that and you can resize Zoom and move it around, put it on the left-hand side, typically. And then the code editor, your code editor is in a browser tab. You can resize your browser. Usually you can do it by just clicking on the top right. There's a little like 2 squares right in this area over here, and you can resize it. So I'm going to give everybody a minute to get that set up. All right. So let's do some coding. So we're going to build a Minecraft game. So let me go ahead and grab the full code for this. Give me just a second. You're going to get all this code in a bit, okay? So it's actually Minesweeper. I apologize. So I'm going to click on one of these cells. Oh, so one of the cells around here has a bomb. Is it this one? Nope, but three of those do. I'm going to go over here. One of those does. Oh, hey. All right. So, oh, let's see. One of these, yeah, that's a bomb. That's a bomb. I love Minecraft. That's not a bomb. That's a bomb. This has three, so that's not a bomb. Doom. Okay. Man, I love Minecraft. Okay, so it's Minecraft. Oh, sorry, Minesweeper. Minesweeper, I apologize. I'm not going to play the whole game, although it looks like I might be able to win here. This doesn't make sense. 1-1. Oh, yeah, here it is. There we go. Boom, 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 boom. Three, boom, boom. Hey, I hit a mine. Oh, no, I wasn't paying attention. So that's the game. Now, you're going to get this full code, but we're not going to try to build this whole thing. That'll probably take a few hours and frankly, wouldn't serve you very well. Here's what we're going to do. I'm going to go over here and I'm going to remove all this code. And now, from this point forward, let me see if I can adjust the font. Nope, come back here. That's not what I wanted. I think I have to do some plus. There we go. Okay, so a little bit bigger. All right. We're going to use this area and we're going to start building each of those 5 elements of a computer program. We're going to use JavaScript to do it. So let's just start by getting something to print on the screen. There's actually a lot of I know it said Minecraft up here. I'm so sorry. I'm going to get that corrected. It isn't Minecraft. That would be a heck of a thing to be able to build. It is Minesweeper, and I will correct that in the future. I apologize. In fact, Cheska, please make a note that we are building Minesweeper, not Minecraft, and change anything that we're putting out there that says that it's Minecraft. Minecraft is way beyond the scope of what we can do in one of these classes. All right, so you're still going to learn something really cool, and Minesweeper is a lot of fun. Let's print something out on the screen. There's actually a lot of learning just from this simple print statement, right? So let's look at, hold on a second. I've got to move a couple things around here to get ready. All right, so let's do alert right here. That's your instruction. Go ahead and type that in, A-L-E-R-T. Do not hit space. Do an open parentheses and then a double quote and type hello from the editor. And then a double quote and a parentheses and a semicolon. Now, let's go to run it with this button here that says run. It won't alert, will it? It just prints it. This editor is being weird. Give me just a second. Okay. All right, good. This is fine. I'm going to be able to do variables and everything I want to. So we have a first instruction. We can print stuff on the screen. That's fine. That's relatively trivial. What I want to show you is how to use variables and how much fun that can be, okay? So I'm going to hit enter a couple of times, and we're going to make a variable. In JavaScript, there's a few different ways to do this, but we're going to use a way that is a command called let. Actually, we'll just do, yeah, let is fine. Let is an instruction to make a variable. You can hit a space after this. Now, I want to explain a bit more about this variable thing. So I mentioned earlier that inside the computer are these devices, these memory storage devices, and you can think of them as billions of little teeny locations. They're physical locations, by the way. Like you can actually, like under a microscope, see these little places on this device that information can be stored. But here's the best way to like conceptualize it. Each of these locations is almost like a bucket. And in the bucket, you can put data, you can put information. But on the outside of the bucket is written a word. And that is something that is a unique name for this bucket. That's what we're going to come up with right now. What's the name of our variable? And let's say that it is bomb. That's the name. And inside that bucket is stored, is there a bomb here or not? True or false? That's all. And so we need to put something inside the bucket. We need to put a value, some data inside the bucket. You do that with this symbol that is an equals. And then we're going to write true. There's a bomb inside the bucket. Of course, you should spell it correctly. We've now made a variable. Now let's use it. Let's have fun and use the variable. So we're going to print something to the screen again. Let's use our alert. Actually, we can just do it this way. I think we can go hello again. I'm going to test this editor out. This editor changed in the last couple months, so something's different here. This is not performing correctly. Give me a second. Something changed about this and it isn't working. I apologize. It's simply putting the content on the right. Oh, I know exactly what's going on. I apologize. Okay. This is totally my fault, and I will get you guys caught up in just a second. Okay, good. So all right. So here's what I want you to type. I'm going to put all of this inside of chat so everybody can get it. This is to everyone. Grab everything from that chat message I just posted and put it onto your screen right here. And I'll explain what I did wrong. I've been teaching Python classes for several weeks now, and I came back to JavaScript and messed up, and I'm sorry for that. All right, so I'm going to give about 10 more seconds for everyone to get all that content and then paste it in here, and then I'll explain what we're looking at. Okay, so here's what we're looking at. We're looking at HTML. The code can't be copied? What happened? All right, follow along with me. Do the less than symbol, it's just to the left of your shift key, and do HTML, and then the greater than symbol. Then hit enter a few times. Do the less than symbol, a slash, and HTML. I'm going to go slow here so people can keep up. Then go below that top line and do less than, HEAD, then a greater than. Hit enter a few times. Actually, don't even hit enter, just hit it once and do the slash, HEAD, like that. Remember, type it exactly like I'm doing it. Then less than, the word body. Hit enter a couple times. And then less than, and then slash body. We're almost ready to write some code. Go underneath body and do less than, script. Hit enter a few times, less than, slash script. I think you're starting to see a pattern here. If you want to, you can remove some of these spaces to make it look nicer. All we care about are these lines right here. That's where we're going to do our work. So I'm going to give a second for people to get caught up. And again, I apologize for the confusion. It's totally me. Now let me explain what we're looking at here. This is hypertext markup language. This is the language for creating a web page. Now, one of the cool things about web pages is you can put JavaScript in them. And your browser will run the JavaScript code. So we're going to do our little programming learning inside this section that starts with script and ends with slash script, because that's where you put JavaScript code. So for example, let's do what I intended to before and type alert and then do an open parentheses and say, hello from the editor, a double quote and a parentheses, and then a semicolon. I'm going to leave it up there so people can figure it out, can copy it. And I'm also going to run it, and I encourage you to run it. And you'll notice then an alert pops up. If it isn't working for you, check that you've written exactly what I have, including these sections. Make sure they're typed exactly the way they are. One of the clues that they aren't typed right is that the colors will be off and kind of weird. That's just a helpful feature of this editor to let you know that there's a problem. All right, now let's get back to where we were and make a variable. We're going to make a variable. Remember I said to create a variable, you use this word let. Then you come up with a name for the variable. We want to have a variable that holds whether or not a bomb is present. So let bomb equal true. So we now have a variable. And we can now use that variable. Let's do another alert. And watch this. We're going to go, is there a bomb? Question mark. Don't hit a parentheses. And then do plus. That's not math. We're not doing math here. We're adding on something after the words. I'll explain that in a moment. And now let's type in bomb, the variable that we have, and only then hit an end parentheses and a semicolon. I'll explain exactly what's going on here in a second. Now, let's see if this works. And notice that the second alert says true, that there's a bomb. So let's talk about this for a second. There's a couple really valuable programming lessons here. The first one is this. Notice how a couple of times we've used this instruction you can hit OK. We use this instruction alert. This is a JavaScript instruction. Clearly, this instruction says, hey, make a little pop-up appear with some text in it. But notice that there is no space after the word alert. All right, Niche says they don't see anything. Niche, here's the things to check. Check that all of these words are spelled exactly the way I typed them, and that all of these words are spelled exactly the way I typed them. Then make sure that there's no space between alert and the parentheses. Make sure that you have an ending parenthesis. In other words, make sure that your content is exactly the way I've typed it. Colin, you're right. It's just habit. All right. Niche, did it work? All right. Look through one line at a time. But meanwhile, this part's really important. So just pay attention here, okay? Okay, if yours says hello from the editor, you have to click it off and have the second alert appear. Remember, we have two alerts. First, it'll do this one, then it'll do this one. I'll run it again. First, I get hello from the editor, and when I click OK, now we move on to the next instructions, and it says, is there a bomb? True. So let me explain a couple fundamentals here. This instruction, alert, in order to be able to do its job, it needs to be given some information. Specifically, it needs to be given what's the text that you want to appear in the alert. And in JavaScript, when you have an instruction that needs data in order to do its job, you wrap that data in parentheses. You can see the parentheses at the beginning and the end of the data. And the parentheses have to come immediately after the instruction that requires information. Niche, it worked. Good job. Excellent. So let's reinforce a couple of fundamentals. Your actual program starts right after this script line. This is where your program starts. So when we run this, first we do this first instruction. We have to click OK, like run it again. We have to click OK. Until we click OK, the rest of the program is not going to happen. We click OK, and we move on to this line where we make a variable called bomb and give it a value of true. And then we perform this instruction, pop up another alert with some text that says, is there a bomb? And this is the important part. Notice it doesn't say, is there a bomb? Bomb. It says true. Why? Because that's the value inside the variable. That's the value inside the variable. Nishat, alert isn't needed for this. It's just a nice, convenient way to actually see your output. That's all. It's a fun way to learn some of these fundamentals. We can print stuff over here too. But I like alerts. So, again, fundamental elements. If an instruction needs information in order to do its job, you pass it that information by containing it with parentheses. Everything inside the parentheses is given to the instruction so it can actually do its job. Now, in a little bit, you're going to make your own instructions. Alert is a built-in instruction in JavaScript. The creators of the JavaScript language came up with it, but you're going to be able to come up with your own. So let's move on to another aspect of variables. Let's make bomb false. Do bomb equals false. Let's spell it correctly. Now, don't run the code. I want to ask a question. I'll give it a second for everybody to catch up, and then going to ask a question. And I'd like to see your thoughts in chat. We're going to have two alerts pop up. First, the one that says hello from the editor. My question is, what is the second alert going to say? Put your guesses in chat. What do you think the second alert is going to say? Perfect. I see a bunch of the correct answer. It's going to say, is there a bomb true? Is there a bomb true? Someone said probably both of them. And then I got true, false. Well, let's run it. Here's the first one. It says hello from the editor. We expected that. Look at the second one. It says true. And now watch. I'm going to click OK. Nothing happens. There's no third alert. I love it, Harry, Emma. That's awesome. Let's talk about exactly why. This one little thing can really disrupt your learning to program. You'll need to start thinking like a computer. A computer can only do one thing at a time, and it does things in an exact order. Good job, Abhiram. That's exactly right. So the computer only does one thing at a time, and it does them in an exact order. So let's start to think like a computer. The computer starts with its first instruction. This is the important part. The computer is completely unaware of any instructions or code after this line. It has no idea that these things are here. They don't exist. Exactly right, Leah or Leia. Those instructions I've highlighted, as far as the computer is concerned, they don't exist because it's reading from the top. It's read this instruction that says alert, hello from the editor, and that's all it knows. And so it's going to do that. And it does it. Let's run. The moment that it's done doing that, and it's not done until I click OK. The moment it's done with this first line, only then does it go on to the next line. Click OK. So the computer went to the second line. It said, oh, a variable. Let's make a variable called bomb. Let's give it a value of true. So inside the bucket that says bomb on the outside, I put true inside there. Okay. It's done with that line. Now it goes on and says, oh, now I need to do an alert. Remember, the computer is still completely unaware of the later instructions. So when it tries to do alert, is there a bomb? And then the value of the variable called bomb, what's the value of the variable called bomb at that exact point in time? It's true. The computer has no idea that you're going to pull a switcheroo and change the value later. It has no way of knowing. It hasn't gotten there yet. So as many of you said, if we want to get this new information displayed to the user, we need another alert. So do another alert and do now is there a bomb? Question mark. Do a space after that just for formatting's sake. And then there's your double quotes and do plus bomb and parentheses and your semicolon. The semicolon indicates that you're at the end of an instruction. All right, now let's run. Hey, there's our first alert right here. There's our second alert. Is there a bomb? Well, at that point in time, the value is still true. Hit OK again. And now it says, is there a bomb? And we get this now changed value and it says false. This is why variables are awesome. You can keep track of the changes in a certain piece of data as the program proceeds, and you can make use of the new values. Admittedly, this is a pretty simple way of making use of it, is try to illustrate that variables are really valuable. And by the way, someone asked, is it because we didn't put let in front of the bomb? Nope. It's just because we hadn't even gotten to that instruction yet. Does that make sense, Harry? It was a good guess. Excellent. Good job. All right. So let me click OK. So we've got an entrance point. This is our first instruction. We've made a variable, and we've shown that you can set an initial value for the variable, but we can change that value as the program proceeds. But now, let's talk about how we make our program make decisions. Remember when I was playing the game, if I click on a square and there's a bomb, then it blows up. If there's not a bomb, then it clears up. It clears the square away. Most of us have played Minesweeper. Now, we're not going to build out the full logic of how to make the little square appear on the screen and then make it disappear and bomb or whatever. We're going to just show you how do you get a decision made based on whether there is or isn't a bomb. How do you make that decision? And more importantly, if you can make that decision, how do you build out two separate things that could occur? Two separate paths or branches. That's what we're going to show how to do. Now, in JavaScript, there's a few different ways to do that. The most common one is an instruction called if. So type if. This is a control instruction. Now, this instruction needs some information in order to do its job. It needs some data that the computer can figure out whether it's true or not. Is the data true or not? So we want to know if bomb is true or false. And if it's true, we're going to do one thing, which is game over. And if it's false, we're going to do another thing, which is no bomb. I'll clear away the square. So instead, like I said, of building out all the nerdy stuff you see in the real game, we're just going to use text to show there's two different things that could occur. But before we do all that, we have to get the decision made. How do we force our program to make a decision? Well, you do it like this. Right after the if, I want you to give me an open and closed parentheses. And then put the cursor back inside there. Inside these parentheses, you have to give the computer something that it can make an unambiguous decision about. No maybe, no ish, simply true or false. And in this case, we want to know, is the variable called bomb, is the value inside it equal to true? That's what we want to know. Let's talk about this little symbol here. It's two symbols right next to each other. There's a special word for this. It's a JavaScript word. It's called an operator. An operator tells the computer to do something very specific. In this case, the operator tells the computer, please compare the pieces of data on either side of me and determine whether or not they are equal to each other. That's exactly what this instruction, you see these two things I have highlighted. That's an actual instruction to the computer. Again, it's called an operator. More precisely, because there's several different kinds of operators, this is a comparison operator. Please compare the two pieces of data on either side of this symbol and determine whether or not they are equal. If they are, then your answer is true. If they're not, your answer is false. And this is exactly what our if instruction needs. It needs to know whether or not something's true or false, because only then can the program decide which of two or more available options should be taken. So what are our two options? Well, the first one is going to be, what if it is true? So go to the end of the line here, hit a space, and then I want a curly bracket. It's right there, just above and to the left of your enter key, and you need a shift to get to it. And now hit enter twice and give me the opposite curly bracket. They call it a closing bracket, opening and closing curly brackets. And we're about to talk about one of the other really important aspects of programming and of JavaScript. We're about to put some code between those two curly brackets. All the code inside those curly brackets is called a code block. And here's the cool thing or interesting thing about it. The code that we're about to put in here will only be performed, it will only be executed if, in fact, the condition right here is true. So what do we want to do? Well, like I said, in the real game, you'll like blow up the board and pop up an alert. We're just going to do something simple. We're just going to hit tab. You don't need to do tab, but it makes your code a little more readable, right? And we're going to say alert. And we're going to say, a bomb. You lose. Like that. That's all. So what do you all think? When we run this and we get to this part of the code, are we going to get an alert that says a bomb, you lose? What do you think? Got a no. Any other guesses? Some more no's. Awesome. Let's run it. Here's our first alert. We know that one. Hello from the editor. Here's our second alert. Is there a bomb? Yes, there is. Here's another one. Is there a bomb? No. Now, nothing happens. Nothing happens. Now, there's a couple of really interesting lessons there about the fact that nothing occurred. Well, I think most of you grasped why this didn't occur. We didn't send up an alert that says a bomb, you lose, because this condition was in fact not true. The value of bomb at the moment of this instruction is still false. But the reason nothing else occurred is that we didn't give it anything else to do. We didn't give it the second branch. This is our first branch right here. It's what happens if the condition is true. We need to provide the second branch, and you do that with an instruction called else. And then do the opening curly bracket, hit enter a couple times, and do a closing curly bracket. And now we have a place to put our second branch. Hadassah? Yeah, I'm simplifying the concepts of the game just to illustrate how to make two different branches. But yeah, if we had the actual game, depends on how I click on the square. If I right click on it, it'll turn it into a flag. But if I just left click on it, boom, it'll blow up. I don't want to do all that complex logic in here. It gets in the way of teaching these fundamentals. That's a good question, though. All right, so what are we going to do inside this code block? Remember, that's the term. Inside these curly brackets is a code block. What we're doing in here is we're putting, what do we want to have happen if the condition up here is false? And what we want to do is send up another alert. You can hit tab, alert. Oh, I didn't have caps lock. Alert. And we go, no bomb. I'll clear the square. I'll leave it there for people to get caught up. All right. So now we should get this alert. Let's run it. Hello from the editor. We've seen that before. Is there a bomb? True. Now is there a bomb? False. And here we should get no bomb. I'll clear the square. And we got it. We now have a way for our computer program to make a decision. A vital aspect of any program. Again, we've made this really simple. Is there a bomb or not? You can get in a little more complex situations when you're writing, more complex programs, but at the end of the day, the principles are exactly the same. You're going to need to make a decision with a control instruction, and you're going to have to choose between two or more possible courses of action. These courses of action are called branches. Here's our first branch. Here's our second branch. A fundamental aspect of programming. All right, let me look at attendees. Colin says it's not working. A couple things to look for, Colin. Do you have a closing curly bracket that matches? You have a closing curly bracket. Those are two things to look for. Is there no space after if? Make sure there's no space after if. Do you have double quotes? Okay. Now you start to think like a computer and literally go through. If you were last working right here, if all that was working, you need to look through every single character here, one character at a time, and find where what you have is different than what I have. It will be there, guaranteed. One individual character at a time. All right. Let's hit enter a few times after the curly bracket to give ourselves some room. And now we're going to hit one of the coolest things. Every single time someone clicks on a square, we need to make this decision. Every time. And there's maybe 100 squares or 64 squares, however big the grid is. So just think about that conceptually. Every time someone clicks, you have to repeat these exact instructions that I've highlighted. This is where the idea of a subprogram comes in valuable or becomes valuable. I don't, as a programmer, want to write these exact instructions over and over and over and over and over again. I would rather package them all up in a little box that is my subprogram. And whenever someone clicks on a button, on a square, just call on the subprogram. And that's what we're going to show you how to do now. We want a subprogram that does these exact instructions every time someone clicks on a button. Well, in JavaScript, this subprogram thing is called a function. Lots of different programming languages use different terms for this exact same concept. They can be called subprograms for sure. They can be called functions or methods or subroutines. They all represent the same thing. I, as the programmer, have identified a series of instructions that I'm going to need to be used in the exact same way many different times in my program. And so I'm going to take those instructions and put a wrapper around them. And I'm going to give that set of instructions a specific name. And then whenever I want those instructions to occur, I'm going to call on them by name and say, hey, please do those things. Please do that voodoo that you do so well. That's what a function is all about. So you're making your own repeatable functions. I'm sure you can think about the fact that this alert instruction, there's a bunch of instructions. They're down inside JavaScript, and they're the same thing every single time. We get to make our own instructions. Now, let's go down, put the cursor after that final curly bracket, and let's make our own function. You do that by, of all things, typing out the word function. And hit space. Now we need to give it a name. I'm going to give it a name that is check bomb. I'm going to check whether or not a bomb is present. Pretty straightforward. I like the name. You can name it whatever you want. You can name it Eric. You can name it Fubar. You can name it George. I'm going to name it check bomb. And you should too. Now, remember how we talked about this instruction called alert, and that it's the kind of instruction that needs some information to do its job. When you make your own functions, sometimes they need information to do their job. And that information goes inside of parentheses. So give me a couple open and close parentheses there. Now, what kind of information do we need? Well, we need the square that got clicked on. What's in that square? That's what we need. So we can put whatever name we want for the information that's going to be given to this function. I like square. We're going to pass in a square. Really, what we're going to pass in is there a bomb in that square? Let's call this information we're going to pass in square. So now we've done a couple really important things here. We've told JavaScript, hey, I'm creating a function. Now listen to this next part really carefully. I'm creating a function that later on, and only when I ask for it to be done, will contain some work for you to do. And that's critical. When you make a function, the work available inside of it, the instructions inside of it, only happen when you ask for them to be happening later on. I'll show you that. So we've said, hey, JavaScript, I'm making a function. This is the name of the function. It's called check bomb. When I give information to the function, call it square. And now we're ready to actually give the function what to do. What are the instructions? So go to the end of the line, hit a space, and give me an opening curly bracket. Hit enter a couple times. Give me a closing curly bracket. This should start to be familiar. We're going to make a code block. This code block is special. What's going to go in here are the instructions that will happen whenever we ask for this function to do its job. And we know what to happen. Go inside and hit tab once. We want to check whether or not the information given to the function has a bomb in it. We'll do this way. If, and then what's the information we were given? We're given this thing called square. And if it equals true, that means there's a bomb. And we kind of know what to do from up above. Let's define the code block or the branch. What to do? Let's define what to do if square is true. Hit enter a couple times and another curly bracket. Go back inside the code block and hit tab. And we're going to do an alert. A bomb. You dead. Like that. Give it a moment for people to get caught up. And now, just like we did before, we need to provide a branch for what to do if square is not true. So hit enter right after this second curly bracket and else. We've seen that before. Space and then the opening curly bracket. Enter a couple times and the closing curly bracket. Go back up inside it. And what are we going to do? Well, we're going to do an alert. You okay? Keep playing. Like that. Now, in order to kind of keep things a little more clean, I don't want to deal with all this earlier code. So I'm going to comment it out. So I'm teaching you about a thing called comments. Go back up here to the first line of code. It says alert, hello from the editor. And do dash dash space. Oh, no, sorry. Slash slash. Like that. That turns it into a comment. That means it's no longer an instruction for the computer. The computer will ignore it and not do anything. Those are really valuable to us as programmers sometimes. Do that for every line. We're taking all this stuff out. Everything except for the function. So all of your code should be green, except for the function. I'll wait for a moment for people to get caught up. And now I have a question. Don't run your code. I want you to guess what's going to happen when we run the code. Put your guesses in chat. Ted says nothing. You're right, Ted. Good. A lot of nothings. Michelle, I don't think that that's actually the correct answer. I think you were typing fast. It said otter. Okay, good. All right, good. So, and then I really love this. This was Miranda said, we don't call the function yet. Michelle, that's awesome. Well, tell your 7-year-old he's hilarious, or she. So yeah, here's the thing. We only created a function called check bomb. We didn't ask for it to be used. You come out of the code by putting these 2 slashes right here before it. Okay, so Nishay, let me explain this part. He was saying, and I understand, there's a lot here, okay? To come out of the code, put these 2 slashes. See, it's not commented out. Slash slash is commented out. Just type those 2 slashes. Okay, so Nishay, let me answer this question. And this is a good question. He said, after alert, a bomb, you dead. I don't understand. So, if is a control instruction. This is where a decision is made. We give it something that is going to be either true or false. That's called the condition. We immediately have to give it a branch of code that will happen only if the condition is true. And we've done that. It's highlighted right here. After that, we have another control instruction that says, if this is not true, if the condition isn't true, then here is the second branch of code. Here's what to do. if the condition is not true. Does that help, Niche? And if I mispronounce your name, I apologize. Did that help? All right. So all we did, though, was create the function. We didn't ask for it to happen. Excellent. Yeah, I really, if I pronounced it wrong, I apologize. Okay, so let's call on it to happen. Let's call on check bomb. And the way you do that is simple. You just type the name of the function and you give it the information you want. Let's say false. There's no bomb there. Before you run this, anyone want to take a guess as to what's going to happen when we run it? Let's run it. And let's talk about this. This next point I'm going to make is actually really vital. And not understanding this can make learning to code in JavaScript or really any language kind of challenging. So I'm going to ask you to pay close attention. When the computer starts reading through the code, first it ignores all of these lines because those are comments. This is the first point where we have some actual JavaScript code. However, and this part is critical, nothing happens when the computer reads all of this code right here. Nothing actually occurs. No work is done. The program doesn't do anything. It doesn't do any work. All that happens is we define a function. We define some, and this is the critical term, potential behavior. We define some potential work that could occur in the future. And that's what makes this line right here so interesting. This is the last line of our tiny little program, but it's the first point where we actually tell the computer to do any work. Kind of cool. And we tell it to do the work by calling on the previously defined function and giving it some information. We give it the value false. So what's another way we could use it? Well, let's say there's a specific variable called square, and it was equal to true because it had a bomb in it. Go ahead and type that out. Now, because someone clicked on that square, let's call check bomb, and we'll pass that variable in, square. We're going to call on check bomb twice. The first time we call on it, we're giving it the value false. We already know what's going to happen. It's going to print out, you okay, keep playing. The second time we call check bomb, we're going to pass in a variable whose value happens to be true. So it's going to print off a bomb, you dead. Let's run it. First time, you okay, keep playing. That's this function call. Now the second one, a bomb, you dead. That's the second function call right here. So we were able to execute these instructions inside here twice with only 2 lines of code instead of 1, 2, 3, 4, 5, 6, 7, 8 lines of code. Times twice is 16. It would have been 16 lines of code to do all this. And we did it with 2 lines of code. Leia, I understand. Here's the points where this can go a little sideways. First of all, make sure there's no space after the name of your function, and you immediately have parentheses. Make sure the parentheses begin and end. Make sure there's no space after the if control instruction. Make sure you're typing exactly the same way, including these two equality, the equality operator, or the comparison operator there. Make sure you've got a final close parentheses. Make sure every time you have a curly bracket that's opening, you have a corresponding closing curly bracket right here and right here. That should help you find it. I'm going to leave this on the screen. I want this to work for everyone. So I'm just going to leave it on the screen for a minute. If it's not working for you, take a moment. And again, think like a computer. Go through it one character at a time. That's literally what the computer does, is it goes through one character at a time. Because computers can't understand anything. They're stupid. It's just got a bunch of rules, and it reads through one character at a time and sees whether what it's reading matches any of its rules. Leia, let me know if it gets working for you or not. And then we'll move on. So I want to reinforce a couple of the fundamentals. We talked about variables. We have a variable here at the bottom, which is square. We set a value of it, and we were able to use that variable in a subprogram, right? A function. We talked about control and branching instructions. We have a control instruction here, if, and it directs whether or not this branch or this branch of code will occur. We get to control that. We can have a computer program make decisions. Excellent, Leia. Okay. And we talked about subprograms. We made one. We made a subprogram. Again, in JavaScript, they're called functions. And this subprogram is what we would use every single time someone clicked on a square. Now, in a moment here, we're going to look at the actual code for the program. And you're going to see that even though it's going to be more complex, it's only going to make use of these 5 things: the entrance point, variables, control and branching instructions, and subprograms. That's all that's going to be in there. So let's look at that code. Cheska, can you drop the link to the code in there? Actually, I've got it super handy. I'll go and grab it right here. Grab that link and grab the code and put it over here, erase everything you have, and paste in that code. And I'm going to give you all about a minute to play the game. Can't believe I lost. I hit a mine. That was fast. Ooh. I won. Yay. Okay. All right. So let's look at the code here. I want you to go to the very top. Now remember, at the top, this is all HTML and CSS. You can ignore this. I want you to scroll down to right here where this script begins. Now, we don't have time to go through every single line here, but I want to point out that we're making use of these core elements. A const is another type of variable. So we have a variable called grid element, and we're giving it some value. Again, There's a little complexity here, but a variable that has a value, a variable that has a value, a variable that has a value. How big is the grid? How many mines are there? Another variable, grid. It's got a value. This is like some empty array or collection. And look, now we make a function. Hey, we made functions. This one's called initialize grid. And even though you can't read all this nerdy detail, you can tell because of the comment, it's going to make the array. It's going to put a bunch of bombs in there. Is it a mine? Look at that. Actually, no, it's just going to set no mines, no revealed, whatever. And then it's going to place the mines at random. It's going to go through here and randomly put a bunch of mines. The comments help, and you can read through the code. Then it's going to figure out what mines, what's next to the mine. Okay. And here's a function. It says, how can I tell how many mines are next door? How many mines are the neighbors? And again, this is pretty nerdy and complex, but we're just using variables. And this is a control statement. There's another function to reveal a cell. This is what we were doing. Is it a bomb? And look, game over, you hit a mine. Now, this is why I said the code is a little more complex in the real game. Here's an if, and here's an else. I wasn't going to lead you all the way through all this nerdy detail. But it's the same thing. It's just a control statement. Here's another function. Toggle a flag on the right click. Here's another function to initialize the game. And look right here. This is where we actually start the game. We set everything up and we define all the functions and then we run the game. So this code is yours to go through detailed if you want to play around with. Probably the 7-year-old would enjoy this. I know I actually love it. I love Minesweeper. I could play it for hours and have. So let's move back over. And I want a little bit of time for Q&A. We've gone a bit over. It's been fun. You have a lot of good questions, but I'm going to watch code here for a second. Nishay, did you get the code? Did you get the link? Okay, good. Excellent. All right, so I'm watching chat. Are there any questions that I missed? Anybody need any questions before we move on? Pop them into chat, and I'll do my best to answer them. And if it'll help, I can go like this and go and put all of my code back to see if this inspires any questions. Okay, Nishay, was it helpful? I know it was easy. I'm glad. Did it help? Awesome. Okay, good. How can we create more games like this? Well, probably a really easy one to start with is literally a tic-tac-toe game, right? Because it does involve creating a grid like this, right? But it's much more simple. It's a 3x3 grid, right? And it's a really good exercise to go through if you're trying to figure out some coding. Okay, good. All right, let's go back. Okay, so let me cover a couple of other aspects here. I'm going to move some of my zoom controls around. Okay, so a bit more detail about who we are, okay? And you guys have been really good to stay this long. Please stick around for your free gift. It'll be here in a few moments, okay? At the Tech Academy, we have 12 different boot camps, and they cover, as you can see, a huge range of technology subjects, including artificial intelligence, computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. Right? In fact, we have more certification programs than any other coding bootcamp on earth. And this is the part that we've worked really hard to implement. Our boot camps are self-paced, yet instructor supported. They're flexible. Students set their own schedule, and you can enroll 365 days a year. The content on them is really well-rounded and in-depth. They're affordable, the price under the national average. Every program includes job placement training and job placement assistance. But most importantly, they're designed for absolute beginners. No technology knowledge or coding experience is required. So you don't have to be a nerd to get through these programs. We consistently land on every major best coding bootcamp list. Our average review rating across all major bootcamp review websites is 4.8 out of 5 stars, and that's based on student and graduate feedback. We're really proud of that. So if you've been considering working in tech, there's a couple of questions you might want to ask, like what's appealing about it? Why work there? Well, it has really good work-life balance, and remote work is increasingly possible in tech. I've worked remote for about 8 years. Love it. It's a very creative industry where you can take a lot of personal pride in your work. It's also a very stable industry that pays really well. And as you apply yourself and learn more, you get regular increases in pay. In fact, the average wage for a software developer in America is $120,000 a year. The average salary across all industries is only about $65,000 a year. So technology pays really well. Thanks, Leah. And yes, we cover React in depth in our JavaScript developer course. Ted, that's a great question. I'll get to that in a moment. Now, I want to be very upfront. There are some barriers for entry to doing a boot camp. There's 3 routes into technology. I already mentioned them: self-study, boot camp, college or university. There are some barriers to doing a boot camp. Money is one of them. It can take thousands of dollars to get through a boot camp. What we've done to help with that is, 1, offer huge upfront discounts, and 2, we have monthly payment options for people that have, any kind of credit situation. But the thing I want to stress here is that truly getting through a Tech Academy bootcamp is an investment in yourself. You're giving yourself very rapidly super valuable skills on the market, which is pretty cool. Another barrier to get through a bootcamp is time. There's a lot of material to get through in a limited amount of time. Some boot camps run all of their training in what are called cohorts. Everybody starts their training on the same day and moves through their training all at the same pace. We don't do that. You lose a lot of good people along the way if you do that. Also, some boot camps have you attend in person, in a classroom, in a building. All of our programs are online. You choose your study schedule, and part-time study is allowed, which means you can study concurrently to holding down a job or whatever other schooling you're doing. And finally, one barrier to getting through a boot camp is you do need to have some technical interest or ability. One thing you may have encountered in terms of your own point of view about your technical ability is that some technology education materials are actually, they may have felt too hard, too difficult. They went over your head. That's not your fault. Many technology educators assume too much knowledge, existing knowledge on the part of the students. With our programs, again, you don't have to be a nerd. It's approachable to anyone, no matter their prior technical knowledge. You can have none and you'll be fine. So you don't have to have any technology background to enroll. So really at this point, there's a couple of questions. Are you working a dead-end job? Or maybe you're unemployed? Is it important to you to work from home, or do you want more time with your loved ones? In other words, is it time for a career change? And if it is, the Tech Academy can be the answer. We're career change experts. That bridge is there because we represent a route into technology for everyone. And we've got over a decade of experience in helping people break into tech. Most of our grads make on average $30 an hour in their first job. And we've got over 1,000 graduates working in tech from everywhere from small companies to really, really big companies like Nike or Facebook or Uber or Disney or Epic Games. We've got people everywhere. As a reminder, we have open enrollment, so I encourage you to answer now. One last thing, we've trialed this for a couple months now and it's gone well. So in this month of September, if you enroll this month, if you can pay up front, you get a huge 50% off tuition discount. Also, if you pay up front and you need a computer, we'll send you a refurbished laptop that you can use for your training and it's yours to keep. Also for September enrollments, there's no sales tax, no matter where you live. We'll pay that tax for you. Also in September, we'll ship you our coding books, including an intro to coding book, our computers and technology simplified book, and a technology basics dictionary. All these books we wrote to help people in their technology journey. Also in September, we'll give you a copy of our career planning guide, which helps you plan out the first 3 years of your career once you break into tech. This knowledge doesn't exist in this form anywhere we looked. The career planning guide is a phenomenal blueprint for how to set yourself up for a really good long-term career. It's a lot of information I wish I'd had earlier in my career. Jack, my co-founder, and I, we wrote this because we couldn't find anything like it. Also, if you join in September, you get 90 days of free access to what's called the Tech Academy Accelerator. This is my favorite thing to deliver. It's a subscription service which gives you access to over 100 free educational videos, but more importantly, it gives you access to the weekly workshops that I put on. And these are different than what you experienced tonight. They are for people who are aggressively either getting into tech or already in tech to help them advance their career much faster. It's a deep dive. We build things, we break things, we do coding. It's open voice and chat and video. And they're a blast to do. And we have those every week on the accelerator. And finally, this is huge. This is why we debated whether or not we're going to do it again in September. If you enroll this month, you get unlimited job placement assistance. That means once you graduate and you're in that job placement portion, we're with you for as long as it takes for you to get that first job. You have full access to our job placement material and our job placement experts. These are the people that all they do is help people get hired. And they've helped thousands of people get hired at this point. So that's a September only thing. We don't know how long we're going to continue this because it's a big investment, in particular on our personnel. Suj, that's a great question. It's both teacher assisted and access to video. There's a bunch of different mechanisms. In a moment here, I'm going to give you a way to get the full picture of how it's done, but we make excellent use of pre-recorded video. I did a lot of the lectures because I really like teaching technology. But you also have access to instructors like 16 hours a day or something absurd. Like we have people all around we have students all over the world. So we have instructors all over the world. So you can get access to an instructor. I think it is 16 hours a day. It's pretty amazing. So again, stick around for your free gift. If this is of interest to you, then here's where to go to find out more. I think Jessica just dropped that. Good. That link is in chat. And when you fill out this quick form, it'll take you to a series of steps that tell you everything about the Tech Academy, including Suj had a great question about, is this teacher assisted or watching video by herself? All of that is answered in those steps afterwards. Much better than I could do justice to in a quick 10-second response. Because the answer is both, but that gets explained in detail in those steps after the form you fill out, okay? So please, if you're at all curious about getting into tech, fill out the form. No obligation, and you'll find out everything about how we do this. We're quite good at it. We take a lot of pride in it. It may not be the right fit for you, but if there's a chance it is, then fill that out. I'm going to take a sip of water while I wait for anybody to fill that out if he needs to. A couple quick things and we're done. One of the first things I want to tell you about is, as we wrap up here, is our referral program. Since our graduates really like us, referrals have been one of the top enrollment sources for us for years. And so we have a 5% commission payment for all referred enrollments. And that's not just for graduates. It's you too. If you've got someone that you refer to us, we keep track of that. And if they enroll, we'll send you a check for 5% of their tuition, which is pretty cool. In a minute, we'll give you a way to do that via email. I mentioned books. We have 7 publications, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults. To answer the question earlier about Harry, one of the kids, one of the attendees has a kid, Harry. We're not allowed to teach kids just by the regulations that exist here in America. Okay. But Jack and I wrote a coding book for kids because we're very passionate about that. So you should get that book. It's awesome. You can find it on Amazon or on our links. We have all the links at the end here. We also wrote a project management book, a dictionary, and a book called You Are Not Stupid, which removes all the mystery from computers and technology. And here is your free gift. It's an actual copy of the Intro to JavaScript book. Now, this is only for people in Australia. So I said that. Oh no, because I was looking at the chat. It's only for people in America. I'm sorry, you Perth people. It's only for people in America. That said, you can get a Kindle version of this for a couple of bucks, or you can get a physical copy sent to you for pretty cheap. They're all on Amazon. I'll give you the links in a minute. I'm so sorry, Harry. Okay, so, but if you're in America, we will send you a copy of this book. This book rocks. Like, we put a lot of work into this thing. How do you make JavaScript easy to assimilate? It goes into much greater detail on the 5 elements of a computer program that we covered tonight, all the fundamental, words and instructions and stuff of JavaScript. It's great. And we'll send one to your house. All you do, you'll see an email address that Cheska just dropped into chat, books@learncodinganywhere.com. Send us an email. Say, hey, I was on the class with Eric. Eric promised me I could have a JavaScript book. Where's my book? You don't need to say it like that. But if you include your emailing address, we'll send you a copy of the book. Gladly, okay? And if you have people to refer, drop that information into that email. We'll keep track of it. So I can give everybody a minute to grab that email address if they want to. And Cheska, can you drop our Linktree link in? We use Linktree to make it easy to find all of the Tech Academy's links in one location. And yeah, Cheska just dropped that link in there. When you go there, you'll see links to our free educational YouTube video playlist, our books, our dictionary, our upcoming meetups, our social media accounts. So please follow us on social media. Look there for the next free classes that are on there. And we would love to see you on more of our free classes. So as a reminder, if you haven't filled out that form, please do so. If you have, then go through and do all the steps afterwards just to learn about who and what we are and see whether it's a fit for you. Okay. Thank you so much, Eric. Absolute pleasure. Appreciate you being here. And that goes for everybody. I really appreciate you taking your time. You could have been doing anything on your Friday night, and I appreciate you taking the time with us. And I will see you at the next class. Have a great evening.